Geothermal Institute was established at the University of Auckland in late 1978, with the first intake of students in February 1979. This postgraduate course is designed to give training in geothermal technology to earth scientists and engineers, leading to a diploma in energy technology after 1 year of full-time study. The Institute is financed jointly by the United Nations Development Programme and the New Zealand Government. Only 25 students per year are admitted to the course. Students and staff are housed in buildings recently completed on the main campus. Lectures are held in the Institute. Here the director, Associate Professor Hochstein, is delivering a lecture to the earth science students.
Electricity production uneconomic. If temperature is less than 200 degrees. It does not mean that you can, when you start to explore a system which only has 200 degrees centigrade, that is presumably uneconomic.
A collection of over 3,000 rock samples from geothermal fields around the world is housed at the Institute. The rocks are used by students to study minerals which have formed by reactions between the reservoir rocks and geothermal fluids. A petrographic microscope is an important instrument to do this, but modern X-ray equipment housed in the geology department is also available. University laboratories are utilized by the Institute for particular studies related to geothermal technology. Here, students of the 1979 course are carrying out a series of experiments in the School of Engineering's Thermodynamics Laboratory, illustrating measurements and principles involved in cooling towers and heat exchangers. During field trips, thermal waters and gases are collected and later analyzed in the Institute's new geochemistry laboratory. Results of these analyses provide information about deep subsurface temperatures and the nature of the geothermal reservoir. Regular weekly seminars are an important part of the course, and here our Nicaraguan student of the 1979 course is seen conducting a seminar on work he has been associated with in his own country.
Eventually they left and we kept on going through our procedure. So the quickest way to define an area this large, once we finished the geology and we had outlined, like I said, priority areas 1, 2, and 3. I'll also mention. The geology was done largely by photo interpretation.
Field trips are an important part of the course, and throughout the year, studies of New Zealand's geothermal prospects and activities are made. Engineers of the 1980 course are seen conducting a field experiment at Wairaki on bore 207. Measurements are being taken to obtain pressure drop data associated with the flow of geothermal steam-water mixtures in pipelines. Non-electric uses of geothermal heat are studied on the course. Application to drying of lucerne is being demonstrated here.
Carries the material through into a grinder, drives it into meal, and where the exhaust, where the dust is coming out of the top, that fan is bringing the material through and...
Lunchtime is both an opportunity to eat and to catch up with note writing. The drilling operation is studied in detail during the course, and a number of visits to drill sites through New Zealand are made during the year. Ministry of Works personnel are on hand to instruct and answer questions.
In the wellhead equipment we've got two hydraulically operated shaper gates. The bottom one is around the drill pipe. This is so that if it comes under pressure when you've got drill pipe in the hole, it flows the well off. Now this is by pumping pressurised bag inside those This is to enable you to pump the bed down with a casing. Bearing, before you get half the bearing life out of it, all your cutting structure is worn away. It's a waste of money. A bit like this with an open roller bearing, and it's got inserts on it, and the inserts aren't even worn when you pull it out, but the bearing's shot, you've wasted $4,000 worth of bit.
Earth science students practice using geophysical and surveying instruments prior to going on one of the Institute's field trips, where they will be used to locate the boundaries of the geothermal system at Natha. Analysis of such data is aided by use of the university's extensive computer facility. A detailed study of many aspects of this important but as yet unexploited field in the north of New Zealand is made by all students. Surface features such as hot pools with gas discharge are visited. We see birds asphyxiated by gas. Visits to the recently completed wells demonstrate the site preparation necessary to drill a geothermal well. The wellhead sealed until required for discharge. Again, Ministry of Works personnel are on hand to discuss in a seminar drilling problems and experiences.
You're talking like a measure expansion, which takes a lot of control of the wellhead, you get that sort of expansion of the wellhead. So we're very particular always we should grout from top to bottom, a complete grout job on the end of the casing. The driller's got to be very careful that it doesn't pull too much. You can never just sit down and pull.
The integration of field and laboratory measurements is of importance. Students are making measurements on a two-phase air-water rig, which simulates the steam-water two-phase experiment at Wairaki shown earlier.
The water will tend to move back down to the soil until it builds up to a certain level and you get a slug and push down.
But not all activities are cerebral, and students can vent their frustrations on the squash and badminton courts or other extensive facilities that are available at the recreation centre.